Coming up on SpaceTime, SpaceX's Starship ready for its first orbital flight. The Black Widow pulsar consumes its sibling and claims that Earth's inner core is driven by a dipole geomagnetic field. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
SpaceX has commenced final assembly of the new Starship rocket in preparations for its maiden orbital test flight, which could happen as soon as this week. The 120-metre tall reusable spacecraft is being assembled at the company's Starbase facility in southern Texas. When complete, it'll be the largest and most powerful rocket ever flown, with almost twice the thrust and power of NASA's SLS Artemis moon rocket. Images of the assembly have confirmed that the rocket stack will include Starship Prototype 24 mounted on top of Super Heavy Booster 7. These are the same two stages that performed the static fire test on the launch pad earlier this year. The orbital test flight will see the Super Heavy booster carry Starship to an altitude of 65 kilometres. Following main engine cutoff and stage separation, the booster will return to Earth, initially splashing down off the Texas coast in the Gulf of Mexico. However, the ultimate plan will see the Super Heavy booster undertake an orientation flip and boost back burn guided by nitrogen jets and aerodynamic fins back towards its launch site. The boost back burn will slow the Super Heavy down in a controlled descent before a landing burn will see the booster touch down vertically on the launch pad, caught and secured by a pair of mechanical arms. Meanwhile, the Starship upper stage will continue to orbit before re-entering the atmosphere and splashing down in the Pacific Ocean off the Hawaiian coast. Eventually, Starships will land vertically back on the ground. This orbital trial will be the system's first test flight since May 2021. Back then, Starship prototype SN15 launched from Starbase, climbing to an altitude of 10 kilometres on 3 Raptor engines and undertaking a series of aerial manoeuvres before landing again. So far, all test flights have only involved the Starship prototypes. The Super Heavy boosters are yet to fly. The 120-ton, 50-metre tall Starship section is 9 metres in diameter and constructed out of stainless steel. It's powered by 6 liquid methane and oxygen-fueled Raptor rocket engines, 3 configured for atmospheric operations and 3 for the vacuum of space. Starship's 70-metre-long, 9-metre diameter, 230-ton Super Heavy booster is also constructed out of stainless steel, and it's equipped with 33 Raptor atmospheric engines. SpaceX boss Elon Musk sees Starship as an interplanetary colonial transport system designed to establish and supply human settlements on the Moon, Mars, and across the solar system. It's fully equipped with a belly heat shield, its own retractable vertical landing gear, and can be refueled in space using unmanned tanker versions of the Starship. Another version of Starship will be equipped with a large payload bay for the deployment of satellites. Further in the future, Starship may also host point-to-point flights around the Earth, allowing you to reach any destination on the planet in under 90 minutes. But Starship's first mission will be to provide the Starship Human Landing System, or HLS, a reusable shuttle for NASA to transport people and up to 100 tons of cargo between the lunar surface and orbiting Orion capsules and later the orbiting Lunar Gateway space station. SpaceX will use Starship to replace the company's existing Dragon spacecraft, as well as their Falcon 9 and Falcon Heavy launch systems. The future has almost arrived. This is SpaceTime. Still to come, the Black Widow pulsar consumes its sibling and claims that the Earth's inner core is driven by a dipole geomagnetic field. All that and more still to come on SpaceTime. A rapidly rotating neutron star has set a new mass record after consuming part of its binary stellar companion. Located some 20,000 light-years away in the constellation Sextans, the neutron star, catalogued as PSR J0952-0607, was already one of the most rapidly spinning pulsars ever detected, rotating at around 707 times per second. Now, new measurements show that it's also shattered the record for the most massive neutron star ever detected, with some 2.35 times the mass of the Sun. In fact, if it wasn't rotating so quickly, it almost certainly would have collapsed to form a stellar mass black hole. Neutron stars are fascinating. They're created out of the core collapse supernova death of stars more than 8 times the mass of our Sun. When a high-mass star runs out of core nuclear fuel, needed to keep them shining through fusion, the balancing act between the core nuclear fusion, which is radiating out, and the force of gravity pushing the star's mass down towards the centre comes to an end, and gravity wins. The instantaneous collapse of all the star's entire mass overcomes what's known as the Pauli exclusion principle. This states that 2 or more identical particles with half-integer spin, that is, things like fermions, cannot occupy the same quantum state at the same time. This results in what we call electron degeneracy, in which positively charged protons and negatively charged electrons are quite literally crushed together, forming neutrons, hence the star's name. The result is this amazing exotic object, dozen or so kilometres across, called a neutron star. These are the densest objects in the universe other than black holes. In fact, even just a tiny teaspoon of neutron star material would weigh billions of tons. PSR J0952-0607 was discovered back in December 2016 using LOFAR, that's the International Low Frequency Array based in the Netherlands. It was nicknamed the Black Widow pulsar following its discovery when astronomers realised that it was cannibalising material off its binary partner. As the binary companion was slowly devoured, the Black Widow grew larger and spun faster, now completing each rotation in a mere 1.41 milliseconds. That means the surface of the star is travelling at some 20% the speed of light. As for the companion star, well, most of it's gone. It's already lost at least 1 solar mass worth of material to the pulsar. In fact, scientists are pretty sure it's now dwindled down to a substellar object, just a few tens of Jupiter masses in size. But the study's authors have succeeded in taking spectra of the extremely faint 23rd magnitude companion star, if that's what it still is, using the 10-metre Keck telescope upon Mauna Kea in Hawaii. Their findings, reported in the astrophysical journal Letters, shows the Doppler measurements indicate an orbital velocity of 380 kilometres per second. Combined with brightness measurements over the orbital period of 6.42 hours, this yields a mass estimate for the neutron star of some 2.35 solar masses. That's significantly more than any other known neutron star. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says the findings are important because no one knows how matter behaves under these most extreme conditions. Even the makeup of neutron stars is a mystery. The interiors could consist of ordinary elementary particles, or they could be completely new forms of matter. Nally says the so-called equation of state will determine how massive the neutron star can get before it further collapses into a black hole.
Yeah, this is an interesting pulsar. Now, there are lots and lots of pulsars known. Many of them have been discovered from Australia with the Parkes Radio telescope, particularly in the early days. And this particular pulsar has the record for being the second fastest spinning pulsar on record, and now it got the record for the heaviest known pulsar. A pulsar is a neutron star that spins very, very rapidly, and as it gives off energy, it seems to flash or pulse every time it spins if it's pointed in the right direction towards your eye.
Like
Thus
a lighthouse.
The name pulsar, a bit like a lighthouse, yeah, and it only sort of sends out these beams of energy in certain sort of 2 directions. And so if you're off axis from that, if you're not it's not pointed in the right direction for you, you won't see it at all. But this particular one is pointing enough in the right direction that we can detect it. And a typical pulsar is about 1.5 times the mass of our sun, but squeezed into a globe only about 20 kilometres or 30 miles across. Imagine that, 1.5 times the mass of our sun squeezed into a ball about 20 k's or 30 miles across. It's super dense, what they call degenerate material. That's a physics term. A teaspoon of pulsar material has so much packed into it that it would weigh about 1 billion tonnes here on Earth, right? So pulsars are really quite extreme things. This particular pulsar, known as PSR J0952-0607, spins on its axis, and get this, every 1.41 milliseconds, with a millisecond being 1,000th of a second. So 1.41 milliseconds. Every time 1.41 milliseconds goes by, this thing, which weighs more than our sun and is squeezing this tiny globe, is spinning that fast. It's incredible. And like many pulsars, it comes with a companion star that's a duo. Because pulsars generally form when you have a giant star that explodes at the end of its life and its core gets squashed down into this degenerate matter. Not quite to the stage of a black hole, sort of one step removed from a black hole. So there are plenty of double stars out there, and if one of the stars is big and it goes bang at the end of its life, you end up with a normal star with a pulsar right next door. So this particular pulsar has a companion star, and it is slowly devouring that companion star, which is why they call it a black widow pulsar. It's pulling gas off its companion star, and as it devours gas from the companion star, obviously it's going to put on weight. The pulsar is becoming more massive. So I said that a typical pulsar is about 1.5 times the mass of the Sun, and this one seems to be about 2.5 times the mass of the Sun, which is very unusual. And I think physicists have a bit of explaining to do to, come up with a reason why it has remained a neutron star or a pulsar at that sort of mass.
Yeah, why hasn't it collapsed into a black hole?
Yeah, why hasn't it gone past the sort of point of no return in terms of mass and squashed itself down into a black hole? So we just don't know. It's interesting though, isn't it? So assuming that all their figures are correct and that they do have a pulsar that's 2.5 times the mass of the Sun, they might have to rethink a few ideas.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come. Claims the Earth's inner core is driven by a dipole geomagnetic field, and later in the science report, a new study warns that 21% of the world's wetlands have already been lost due to human development. All that and more still to come on SpaceTime. Scientists have found that the structure of Earth's inner core is driven by a dipole geomagnetic field. A geomagnetic field is generated in Earth's deep interior and extends far out into space, protecting our planet from cosmic radiation and the stream of charged particles constantly flowing out from the sun and the solar wind. The magnetic field itself is generated by the convection of charged molten iron fluids in the Earth's liquid outer core. But in contrast to the convective homogeneous outer core, the Earth's inner core is solid, inhomogeneous, and anisotropic. Seismic velocity in the polar direction is known to be about 2 to 3% faster than in the equatorial direction. Now, a report in the journal Nature Communications by researchers from the Chinese Academy of Sciences suggested the Earth's anisotropic inner core structure is driven by the dipole geomagnetic field. These new findings follow a study published in the journal Nature last year, which revealed that Earth's inner core is not a normal solid, but a composition of solid iron and liquid-like light elements, including hydrogen, oxygen, and carbon, all in a superionic state. In the new study, the authors found that a hexagonal closely packed iron-hydrogen alloy exhibited both seismic anisotropy and hydrogen ion diffusion anisotropy under the sort of high pressure and temperature conditions expected to be found in the Earth's inner core. The authors say that in the presence of an external electric field, the alignment of the iron-hydrogen lattice with the c-axis pointing in the field direction was energetically favourable, and due to this effect, the alignment of the iron-hydrogen lattice could be driven by an electric field. They believe that the electromagnetic field distribution in the inner core suggests an interaction between the inner core and the planet's geomagnetic field. They say the alignment texture driven by the geomagnetic field exhibited significant seismic anisotropy, which explains the anisotropic seismic velocities in the inner core. The study's lead author, Dr. Sun Sichuan, says that beyond the geoscience implications, the unique physical properties of the superionic effect are also vital for science's understanding of the behaviours of superionic matter under the extreme conditions in other planetary interiors. Study co-author Dr. He Yu says it's intriguing that mobile hydrogen inside the Earth's inner core may correlate with a geomagnetic field and thus form anisotropic texture, which should give scientists a new perspective to understand both the mysteries of the Earth's inner core and its magnetic field. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists regard wetlands, swamps and marshes as among the most important ecosystems on the planet. However, a new study has found that a fifth of wetlands that existed across the world in the year 1700 have now been lost due to human activities. The findings, reported in the journal Nature, are based on studies covering over 3,000 international and regional records of wetlands covering some 154 countries. The data shows an estimated 3.4 million square kilometres of wetlands have been lost since 1700, equating to around 21%. Much of this loss occurred in Europe, China and the United States, with conversion to crop and urban development the most common causes. Researchers at RMIT University have developed a cheaper, more energy-efficient way to produce hydrogen directly from seawater, a critical step towards a truly viable green hydrogen industry. The new method splits seawater directly into hydrogen and oxygen, thereby skipping the need for desalination and its associated costs, energy consumption and carbon emissions. Hydrogen has long been touted as a clean future fuel and a potential solution to critical energy challenges. But almost all the world's hydrogen currently comes from fossil fuels, and its production is responsible for around 830 million tonnes of carbon dioxide release annually. But emission-free, that is green hydrogen made by splitting water, is so expensive that it's commercially unviable and accounts for just 1% of the total hydrogen production. To make green hydrogen, an electrolyzer is used to send an electric current through water, splitting it into its component hydrogen and oxygen atoms. These electrolyzers currently use expensive catalysts and consume lots of energy and water. In fact, it can take about 9 litres of water to make 1 kilogram of hydrogen. And also they produce a toxic byproduct, chlorine. This new approach uses a special type of catalyst developed specifically to work with seawater. The inventors say it can be manufactured cost-effectively, it takes very little energy to run, and it could be used at room temperature. While other experimental catalysts have been developed for seawater splitting, they're all complex and hard to scale. This new approach focuses on changing the internal chemistry of the catalyst through simple methods, which also makes them relatively easy for large-scale production. In fact, the technology could reduce the cost of electrolyzers enough to meet the Australian government's goal for green hydrogen production of $2 per kilogram, making it competitive with fossil fuel-sourced hydrogen. The next stage in the research project is the development of a prototype electrolyzer that combines a series of catalysts to produce large quantities of hydrogen. We'll keep you informed. New research shows that Australians tend to have a higher level of trust in scientists when they're talking about vaccines and weather forecasting rather than when they're talking about climate change or genetically modified crops. The survey of around 1,000 people, reported in the Australian Journal of Social Issues, found that people's trust in science varies according to the type of science they're dealing with. 70% of Australians place a great deal or quite a lot of trust in scientists when it comes to weather forecasting and vaccines. But only 58% have the same level of trust for climate science, and only 41% trust scientists to be on the level when it comes to discussing genetically modified crops. The study also found that younger, tertiary educated and politically progressive Australians tend to be the most trusting group. In fact, people who identify as green supporters and environmentalists are most likely to trust all types of science in the study, including GM crop science. Well, it seems squatchers, that is, people who believe in the existence of a giant 3 to 4 metre tall human-like primate, commonly referred to as Bigfoot, are upset that the popular online encyclopedia Wikipedia has kept the mythical beast in the fiction section. They insist the overwhelming number of sightings, both of the creature itself and its tracks, deserves more respect. And they also point to the ancient native pictographs showing images of what appear to be giant Sasquatch. Of course, tales of wild, hairy hominids exist throughout the world. North America has its Sasquatch or Bigfoot, but then in the Himalayan mountains you've got the Yeti, or abominable snowman, and even Australia has its Yowie. In fact, there are a lot of cryptozoologists who genuinely believe the creature is real. They argue that Bigfoot could be a relic population of the extinct Southeast Asian ape species Gigantopithecus blacki. Gigantopithecus blacki was between 2.7 and 3.7 metres tall, so the size is about right, and around 300 kilograms in weight. However, biologists now believe that Gigantopithecus blacki was quadruped, as its enormous mass made it difficult to adopt an upright bipedal gait, and Bigfoot is definitely bipedal. The other problem squatchers have is the complete lack of any scientific evidence. There are no Bigfoot bodies, no remains of any sort, not even roadkill, and hair samples purported to come from Bigfoot always turn out to be something else, so there's not even any DNA. Other than their tracks, the only real evidence is vision of Sasquatch, and that's often limited to distant blurry images now commonly referred to as squatch blobs. The best film ever taken of Bigfoot was the famous Patterson-Gimlin footage shot at Bluff Creek in Northern California back in 1967. That was claimed to have been a film of a young female squatch. However, in 1999, Bob Hieronymus finally went public, admitting that he was the figure depicted in the Patterson film. He claimed that he had not previously publicly discussed his role in the hoax because he was afraid of being convicted of fraud had he confessed. But after speaking to his lawyers, he was told that since he had not been paid for his involvement in the hoax, he could not be held accountable. Then in 2002, a local fancy dress costume maker, Philip Morris, confirmed that he was the one who made the gorilla costume that was used for the Patterson film. Now, even if you discount those confessions, the expert consensus is still that the claims of the existence of Bigfoot are just not creditable. They're either misidentification, most likely bears. In fact, Bigfoot sightings tend to increase with an increase in the population of black bears in North America. Alternatively, they could be the result of confusion or delusion, or they're simply hoaxes, people wanting to big note themselves. Tim Mendham from Australian Skeptics says there is simply no scientific evidence to support the claims.
Wikipedia is constantly being edited, and that's part of the problem that some people who believe in cryptozoology, the study of unknown animals that either never existed or didn't exist in this place or are out of time.
Oh, Bigfoot's so real, they're bouncers at my local club.
Yes, a lot of people equate those. But what the cryptozoologists, people study this thing called cryptids, which is an unknown creature or a cryptical creature. The problem they're saying with Wikipedia is that Wikipedia is sort of downgrading their field of study. For a start, it's always referring it as a pseudoscience. They don't like that. Fair enough. You can imagine that. They see themselves as searchers after the truth. The trouble is it pseudoscience or what they're doing is bad science because they haven't come up with any proper evidence, let alone proper studies. Okay. And what I always say about evidence is that one piece of evidence, one fuzzy photo, one lock of hair, one footprint, if you get one piece of evidence which is worth 2 out of 10 and you get 5 of them, you don't have a 10 out of 10, you have 5 that are worth 2 out of 10. So the more junk evidence you have, the junkier the theory has to become, certainly from a scientific point of view. So is it pseudoscience? Is it bad science? Is it a non-science? Can you really regard it as a scientific endeavour when you cannot or have not been able to sort of, one, explain your phenomenon in their terms? Others might explain it by saying it don't exist. But the issue is that can you explain it? Can you study it? More than just through anecdotal evidence and things and pure luck to walk through the middle of the Washington wilderness at the middle of the night wearing your camouflage outfits with your night goggles and that sort of thing, and you come across a noise and you say, that's a Bigfoot. Well, that's pretty poor science.
Yeah, it's always worried me that when they try to find these Bigfoots or feets or whatever, these Sasquatches, they always do these mating calls. I mean, what happens if one of them responds?
Well, Sasquatches are always interested in, no, they're not actually interested in interacting with humans. They don't like it, apparently. But of course, you presume they're breeding out there, and so there has to be more than one.
Well, apparently all the time, according to finding Bigfoot.
Oh, there are stories, of course, of people being kidnapped and interfered with, same as aliens do. But I mean, it applies to all these cryptids, unknown animals, and the Wikipedia is tuning down or sort of cutting away a lot of the examples that a cryptozoologist might regard as a good example of
What is funny is a lot of these people who are allegedly being interfered with aren't usually the sort of people who would...
If you're an 8-foot hairy person, are you going to be choosy? That's the sort of people you want. But anyway, the Wikipedia keeps cutting away some of these examples, putting them down, not an unknown animal, this is folklore, right? Or this is a scientific phenomenon or natural phenomenon that's got nothing to do with a living being. And therefore they're cutting out things like, obviously, like fairies and will-o'-the-wisps and all sorts of... The jackalope is one that's raised all the time, which is a totally fabricated creature, which is a mixture of a jackrabbit and an antelope, along with a rabbit with horns. And the cryptozoologists couldn't really count that because it's made up, and made up recently, in the same way as a drop bear is made up recently, and you really can't regard that as a real life form, can you? It's an obvious myth to scare American tourists, basically, of a koala that's going to drop on your head and eat your brain. So there's a lot in the cryptozoology world which is really unscientific, needs to be pared away, and that's what the authors and the editors of Wikipedia are doing. Now, some cryptozoologists are saying they're being too rough, too much pairing, too much they're unsympathetic to our field. Well, it's up to the claimants to prove their field, to prove that their study is a worthwhile scientific study, and so far there's not a lot of evidence to support it.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.